This question is asked in GATE 2023 of electrical. This is from network subjects and related to the transient topic. The question is, the circuit shown in the figure is initially in steady state with the switch K in open condition and K bar in closed condition. The switch K is closed and K bar is open simultaneously at the instant t equals to T1, where T1 is greater than 0. The minimum value of T1 in milliseconds such that there is no transient in the voltage across 100 microfarad capacitor is dash. This is one of the excellent questions, students. In fact, a very good logical question. Okay. So because if you see, you have a practical AC current source and you have a practical DC voltage source. So both AC source and DC source are present along with two switches. We are supposed to find a condition that when the switching should happen, so that there is no transient response at this particular capacitor voltage. No transient response means there should not be an exponential term. That's what they're asking. So first thing is, so the switching is happening at the instant T1, right? So switching is happening at the instant T1. So what is the situation for T less than T1? So for T less than T1, if you see, they're saying that for T less than T1, so K is in open condition, K bar is in close. So K, it is open and your K bar is closed. So if I draw the circuits by taking this into consideration, so how does it look like? If you check, students, so it will be like this. So this is your 10 ohm resistor, and then this is your current source. K is open, so K is open here like this, and your K bar is closed. So K bar is closed means this is like a short circuit. So this is your 10 ohms and this is your 5-volt battery, right? And then this is your 100 microfarad capacitor. Okay, and my interest is on this VCT. So I have to calculate VCT. So students, to get this VCT, so one of the simple thing I can do is I can do this source transformation to this practical current source, so that it will be a single loop. Calculation will be somewhat easy. We can do like this also, but we prefer to deal with simple circuit rather than complicated circuit, isn't it? So if I do source transformation to this particular segments, so you get this resistance 10 ohm, this is in series, and you get a voltage source whose value is 10 into this thing. So it is 10 sine 1000 t. So you get this is 10 sine 1000 t. Now student, you see, this is what is your AC source and this is what your DC source. But DC source is kind of nullified because this is a sorted path and this is in parallel with this one. So we are not getting any voltage here because of the sorted path. So DC source is kind of deactivated the way the circuit is given. Only AC source will act. In other words, VCT voltage, if you write the KVL, so VCT voltage equals to this drop plus this drop plus this drop. This drop is 0, right? So VCT is only affected by presence of this and this. This is kind of a dummy element. I mean, if you want, you can simply ignore it in this case. So let us find this VCT. So let us do one thing. Let us write the expression of VCT. But here, what do you think? The network is in what? Steady state or not? Yes, definitely the network is in steady state. Network is in steady state. Rather, I would say it is in AC steady state. Why? Because this has happened long back, right? And you have the AC source connected. So you have to apply the sinusoidal steady state analysis in this case. So in this case, so now if I tell you to write its corresponding phasor domain equation, because sinusoidal expression we are expecting. So what is the notation you will be having? So let us say that I am taking the sine as the reference. So phasor notation of this is 10 at angle 0. This is R and this will be 1 by j omega c. So, so if I write what is your VC phasor notation, it is 1 by j omega c divided by R plus 1 by j omega c multiplied by the source voltage, which is 10 at an angle of 0, the phasor notation of the source. So now you multiply j omega c in both numerator and denominator, you get this 1 by 1 plus j omega rc, and this is 10 at an angle of 0. But what is this omega rc, students? So omega rc, if you evaluate it, so omega is the source frequency, which is 1000. And what is r? R is 10 and c is 100 into 10 power minus 6. So if you check it out, so this is coming as 1, isn't it? Omega RC product is coming as 1. So now if you simplify it here, it is 1 by 1 plus j, and this is 10 at an angle of 0. So this is equivalent to 10 at an angle of 0 divided by magnitude is root 2, and this is at an angle of 45 degree. Tan inverse of 1 by 1 is 45 degree. So this, if you solve it, so this is coming as 5 root 2 at an angle of minus 45 degree. So if you write its corresponding time domain expression, VCT is equals to 5 root 2. Reference was sine, so sine. Frequency will never change, frequency is 1000, t minus 45 degree you can write, or minus pi by 4 in terms of radian you can write. So this is what is my VCT expression. This is valid for what? This is valid for t less than t1. Okay, we'll be making two analysis. One is for before switching and one is for after switching. So now let us see what is going to happen after switching. So for t greater than t1, students, for t greater than t1, so what is happening for t greater than t1? So they are saying that your switch K1 is closed and your this K bar, this is open. K is closed and your K bar is open. So let me copy these circuits so that I can easily, So if you, so now K is closed and K bar is open. So how does the circuit will look like? So the circuit will be, so this is your 10 ohm resistor, this is the current source, and this K is closed. So K is closed means this switch is, it will work like a short circuits. This is your 100 microfarad capacitor, and this switch is like a open circuits, and now you have this 10 ohm is in series with this 5 volts. Okay, and this is what is my VCT is. Is that no? So now you see, students, so this is a sorted path, and so this sorted path is in parallel with this one. So now if I find VCT, so VCT, if you write the KVL, so this drop plus this drop plus this drop equal to 0 by KVL. This plus this equal to 0. So this is anyway 0. So this VCT is influenced only by these segments. So it's a classic case of first order RC network with DC excitation or step excitation, you can say. So even though this AC source is present here, so it is kind of nullified as far as this circuit is concerned, or even if you want, you can simply ignore this as far as this question is concerned. So anyway, let us see now what is going to happen in this case. So you know very well that in a first order RC network having DC or step input, the capacitor voltage VCT is given as VC infinite plus VC 0 minus VC infinite into e raised to power minus t by tau. This is what is generally given. But here, instead of writing 0 minus, we should be writing, so what should be writing is, we should be writing it is VCT1. Because that is 0 minus we have written here, because we assume the switching instant is 0. So you can write here VC of T1 or VC of T1 minus, no problem. Okay, minus VC of infinite e raised to power minus t minus t1 divided by tau. Why I am writing it is t minus t1? Because the switching is happening at any other instant other than 0. So that is what the shifting we expect. This is applicable for t greater than t1. So what is VC of infinite in this case? So Vc of infinite, if you try to get in this case, so that is nothing but equals to how much? 5. Why? Because at t equals to infinite, this will work like open circuits. If it is a open circuits, so this voltage is definitely equal to this source voltage you will get. So in this case, I can tell that my Vc of infinite is equals to 5. Are you getting or not? Because if this is open circuits, if this is removed, so this voltage equals to nothing but this voltage. So this is something like this. You have a 10 ohm resistor, you have a 5 volt supply, and you have this capacitor which is open circuit. What is this voltage? This voltage is same, na? If this is 5 volt, then this will also be 5 volt. That's what I'm saying. So Vc of infinite is 5 volts. So now if I say what is VCT, so VCT is equals to 5 plus VCT1 minus 5 into e raised to power minus of t minus t1 divided by time constant tau. So tau is RC. So let us write tau and applicable for t greater than t1. And what is the time constant if you want? So tau is equals to RC. So 10 into 100 into 10 power minus 6. So this is the time constant tau, RC products. But the point is, students, the question they're asking is, there should not be any transient, there is no transient in voltage across 100 microfarad capacitor. So see, this is the expression which is valid for VCT for t greater than t1. And we expect in this response, there should not be any transient part. If there is no transient part in this response, in other words, there should not be exponential term. This is the transient part, this is steady state part. So this term should be 0. So we expect, so this term should be 0. So that means, in other words, we expect that VCT1 minus 5, this should be 0. If this term is 0, then automatically it will be having only this 5, the steady state part. That's what they are saying, right? So you see what they're asking. So switching is happening at T1, where T1 is greater than 0. The minimum value of T1 in milliseconds such that there is no transient in voltage across 100 microfarad capacitor is. That means after switching, after T1, what is that value? Okay. So that there is no transient in the response. So VCT1 minus 5 equals to 0. So in other words, we expect that VCT1 is equals to 5. So how do you get VCT1? So what is the T1, by the way? T1 is the switching instant, right? So we have this VCT expression. So this is applicable just before switching. So if you want the value of T1, you can simply substitute here T1. So VCT1 is equals to, so let me copy this. Yeah. VCT1 equals to 5, right? So VCT1 is equals to 5 root 2 sine of 1000 T1 minus pi by 4. So this implies, so this is 5 is equals to 5 root 2 sine of 1000 T1 minus pi by 4. 5 cancel out. So 1 by root 2. So sine of 1000 T1 minus pi by 4 is equals to how much? 1 by root 2, if I am not wrong. Right? So that means 1000 T1 minus pi by 4. What is this? What is the value of this sine inverse of 1 by root 2? So sine inverse of 1 by root 2 is pi by 4 again. So this implies 1000 T1 is equals to pi by 4 plus pi by 4, which is 2 pi by 4. 2 pi by 4 is equivalent to pi by 2. So what is T1? T1 is pi by 2000. If you evaluate what is pi by 2000, so this happens to be 1.57 into 10 raised to power minus 3 second, which is equivalent to 1.57 millisecond. So the answer of this problem is 1.57. This is a very tricky question, students, and the students who are having very good analysis skill, I believe only they could have attended this problem in the exam hall. Otherwise, like all people generally who are comfortable in transients, they may not be able to attempt it, at least in the exam hall, I believe. Not a very tough problem, but yes, it's a logical and skill based question. You should have, analysis skill to answer this. So, to summarize what I did in this problem is, so first thing is, you should not be in a mind like the switching is happening at t equal to 0 the way it happens in most of the cases. So that is what is the main point is. So the switching should happen at an instant t1 such that there is no transient for this capacitor voltage beyond that. Okay. So that's what is the point is. So for that, this is what the expression we obtain for t greater than t1, and if you are expecting there should not be any transient response for this time interval, so this part should be 0. So this part should be 0. We got the condition VCT1 equals to 5. So how to get this VCT1? We already obtained that VCT, right? So you can make use of this expression to get the value of the capacitor voltage, so just before the switching. So in the limiting case, we can substitute the value of T1. And then by doing this math, we are getting the answer as 1.57 milliseconds. So answer is 1.57 millisecond for this. This question is asked in GATE 2023 of electrical. This is from network subjects and from two-port network topic. The question is, the admittance parameter of the passive resistive two-port network shown in the figure are Y11, Y22, Y12, Y21 value are given. The power delivered to load resistor RL in watt is how much? So what is the power delivered to RL? So by standard notation of two-port network, so overall two-port network is this one which I am highlighting by these dots. So the terminal voltage V1 and this terminal voltage is V2. And the two-port currents are assumed to be entering into the terminal. So this is I1 and this is my I2. So I'm supposed to find what is the power delivered to load resistor RL. So if this current is I2, I can say then power of RL is nothing but equals to I2 square into RL. RL value is 6. I2 square into 6. Or minus I2 square into 6, doesn't matter what current you take, whether plus I2 or minus I2. Okay, so but to be very specific sense, friends, it should be actually minus I2 because resistor is a passive element. You are supposed to follow the passive sign convention because the polarity I have given plus minus V2 in this direction. So my reference current should be entering plus to minus. If this current is I2, then this current is in opposite direction. So this current is nothing but your minus I2. So that's why, to be very specific sense, it should be minus I2 square into 6. Although you take I2, it will not affect the answer, but to be in more correct way, it should be minus I2 square into 6. So ultimately, my goal is to find the value of I2. So that will give me the answer. So let us see. So student, you can see here, I hope you agree that this two-port network and this resistor, they are in parallel. And we have studied whenever two-port networks are connected in parallel, we can add their individual Y matrix to get the overall Y matrix. In other words, this is a two-port network, this is a two-port network. You know the Y matrix of this, you know the Y matrix of this. You add these two Y matrix, that will give you the Y matrix of this whole thing. Okay, so now I'd like to tell you that this particular single element, which is, let's say, R, okay, its Y matrix, if you try to find it out, so the Y matrix of this happens to be 1 by R, minus 1 by R, minus 1 by R, and 1 by R. All are in Siemens, students. So here I would like to say that I have a 3 ohm resistor, okay. So this is one two-port network. Its Y matrix will be 1 by 3, minus 1 by 3, minus 1 by 3, and 1 by 3. And I have one more two-port network, okay, which is in the box format. And if you see, its Y matrix is specified in the question. Y11 is 5 Siemens, Y22 is 1 Siemens, Y12, and this is minus 2.5 Siemens. Okay, these all are in the Siemens units. So let us say this is Y1 and let us say this is Y2. My claim is this two-port network and these two-port networks are in parallel if I observe these segments. So I can say my Y equivalent, the overall Y matrix of this segment, okay, which I am highlighting, the overall Y matrix of this will be equivalent to Y1 plus Y2. If you add it, it is just like a point-to-point addition. So if I add like this, that means how do you add to matrix? Element to element. This should be added with this, should be written here. This should be added with this, should be written here. This should be added with this, should be written here. This should be added with this and should be written here. So 5 plus 1 by 3, if you do it, I think this is coming as 16 by 3. Then minus 1 by 3 and minus 2.5, that is coming as minus 17 by 6. This is also minus 17 by 6. And this is how much? 1 plus 1 by 3. So that happens to be 4 by 3. So this is what is the Y matrix. So I know the Y matrix of this overall highlighted part. So we can write this Y matrix in terms of I1, V1, V2, I2. So in the Y matrix, you know that the format is I1, I2 is expressed in terms of V1, V2. So from this matrix, I can write that my I1 is equals to 16 by 3 into V1 minus 17 by 6 into V2. I2 is equals to minus 17 by 6 into V1 plus 4 by 3 into V2. But what is my goal? My goal is to get the value of I2 because my final answer needs this I2. So how do you get I2? So you have two equation and you have 4 unknown. So directly we cannot get. So you need to have something else. So what is that something else is? By observing this pattern, I can tell that the value of V1 equals to 20. Yes or no? By observing this one, I can tell that V1 equals to 20. Similarly, value of V2 is equals to minus 6I2. Because if this current is minus I2, this is 6. So what is V2? So V2 is equals to this resistance into this current. So V2 is equals to minus 6I2. So you write here V2 is equals to minus 6I2. What is your goal? Your goal is to get the value of I2. So what I'll be doing is I2 is present in this equation. So let us substitute the value of V1 and V2 in these two in this equation. If you do it, so you see that this equation will be in terms of what? So if you substitute this one, 1 second students. I2 is equals to, is that fine, everything? Yeah, so what we can do is instead of substituting this in the first equation, so let us substitute here. So if you substitute here, our job will be over because V1 it's a number. Okay, so this is a number. V2 is in terms of minus 6I2. So this equation will be in terms of I2. We can get the value of I2, right? So let us do that. So I2 is equals to minus 17 by 6 into 20 because V1 is 20 plus 4 by 3 into minus 6I2. So if you simplify it now, I2 plus 24 by 3 is 8I2. 8I2 is equals to minus 340 divided by 6. So 9I2 is equals to minus 340 by 6, or your I2 happens to be minus 340 divided by 54. I2 is minus 340 divided 54. And if you check it out, so this is happening to be minus of 6.29 ampere. If I2 is minus of 6.29 ampere, then your minus I2 is 6.29 ampere. Right? So you got I2 as 6.29 minus 6.29. I2 is minus 6.29, so minus I2 is 6.29. So minus I2 is 6.29. So 6.29 whole square into 6. Take a calci and simplify this, and if you do this, so this answer is coming as 237.86 watts. So this is the answer. So the answer is 237.86. So this is again, students, very repetitive model question in the GATE exam from last 7-8 years. Every year in every paper there is one question from this terminated two-port network. That is, you'll have some two-port network and it will be terminated by a source and load. So sometimes they're asking what the Thevenin voltage, sometimes they're asking what the maximum power transfer, sometimes they're asking what is the power transfer, like this they're asking. So which is a very regular model. So here directly the matrix was not given. So using the interconnection of two-port network by adding the individual Y matrix, we obtained the overall Y matrix, and then by expanding its corresponding equation, and by observing V1 equals to 20 and V2 equals to minus 6I2, we obtain the value of I2, which happened to be minus 6.2 ampere. And then by substituting here, because we are supposed to find the power of 6 ohm, so the current is minus I2. By substituting that value of I2, we are getting the answer as 237.86. So the answer is 237.86 for this. This question is asked in GATE 2023 of electrical. This is from network theory subjects and from AC network analysis topic. The question is, for the circuit zone, if I equals to sine 1000 t, the instantaneous value of Thevenin equivalent voltage across terminal AB at t equals to 5 millisecond is how much? So we are supposed to find the Thevenin equivalent from this terminal at a specific instant of time, that is t equals to 5 millisecond. So how do you solve this problem? So let us do one thing. So for making the calculation easy, so let us transform this practical current source into practical voltage source using source transformation. And if I do that, so how does this circuit look like? So this is 10, this is minus J10, this is the dependent source, this is plus, minus, this is 4Ix. And then you have, if you are doing source transformation in these segments, so you'll have in series 10 and J10, this is 10, and then you have this is J10, and you have the practical voltage source plus minus like this. Okay, so this, what is the value of this? So the phasor notation of this is, let's say, 1 at an angle of 0 by taking sine as the reference. So if it is 1 at an angle of 0, so this notation will be 1 at an angle of 0 multiplied by this thing. So it is simply 10 plus J10. So this is 10 plus J10. Are you getting or not? So this I am multiplying with this impedance. So 1 is any multiplied with anything is anything. So this is what the thing is. And where this Ix is defined, so your Ix is, this is what your Ix is defined. And this is my terminal A and this is my terminal B. So this is what your Thevenin voltage VTH. So what is the VTH answer then? So your VTH answer is nothing but 10 minus J10 into Ix, right? So VTH answer is 10 minus J10, this impedance into Ix is this voltage, right? So you have to get the value of Ix. So how do you get Ix? So very simple, we can write a KVL at this mesh. We will get the value of Ix. So let us write that KVL equation. So if you write the KVL equation, you get 10 plus J10, I mean this is the voltage source, minus 10 plus J10 into current Ix plus 4Ix plus 10 minus J10 into Ix equals to 0. Is that fine? So 10 plus J10 minus 10 plus J10 into Ix plus 4Ix minus 10 minus J10 into Ix equals to 0. So here there is a mistake, student. It is minus, right? This is minus. Minus to plus, plus, minus to plus, plus. So these are, minus, minus, and will get, as usual, the passive sign convention. So now let us open up these brackets and let us get the value of Ix. So if we simplify this, you get 10 plus J10 minus 10 Ix minus J10 Ix plus 4 Ix minus 10 Ix plus J10Ix equals to 0. Minus J10Ix plus J10Ix cancelled out. And so how much is left then? So if you see now, so this implies you get 10 plus J10 is equals to, if you take to other side, you get 10Ix, okay, this one, plus 10Ix and minus 4Ix. So this implies 20 minus 4, 16Ix. 16Ix equals to 10 plus J10, or your Ix happens to be 10 plus J10 divided by 16. This is what is the value of Ix. But if you see, this is what is your VTH. So if I ask you what is VTH, VTH is 10 minus J10 into Ix. So let us substitute this value, which is 10 plus J10 divided by how much? 16. If you check, this is a square minus b square. This is coming as 10 square plus 10 square divided by 16, which is 200 by 16, which is 50 by 4. And if you check it out, so this is coming as 12.5 volts. So this is your VTH, 12.5 volts. So VTH, the phasor notation is 12.5 at an angle of 0. But what is the time domain notation? Time domain notation is 12.5 sine of 1000t, because we are not getting any extra phase, so the phase angle is 0. So this is what VTHT is equals to 12.5 sine of 1000t. But what is the question they are asking? The question they are asking is what is its value at t equals to 5 millisecond. So let us substitute t equals to 5 millisecond into this. So if I substitute t equals to 5 millisecond, so it is 12.5 sine of 1000 into 5 into 10 raised to power minus 3. If you check it out, so this is coming as 12.5 sine of how much? 5. Now you take the calculator in the radian mode, because radian per second is the unit of frequency and this is second. So you are left with radian. This is radian. Don't put the calculator in degree mode in a hurry. So if you check, so this is 12.5 and sine 5, if you put in the radian mode, this is minus of 0.958. And if you multiply this, so this is coming as minus of 11.98 volts. So the Thevenin equivalent voltage across AB at t equals to 5 millisecond is minus of 11.98 volts. So, like if you do the source transform, students, so the way the data is given, the values are given, so the calculation is not getting too much lengthy. Somehow it is okay, right? So by doing source transform, this single loop, by writing the KVL, you got the value of Ix, then VTH is Ix into this impedance. We got VTH, so then by substituting t equals to 5 millisecond, answer is minus 11.98. So answer is minus 11.98 for this. This question is asked in GATE 2023 of electrical. This is from network subjects and from fundamental topic. The question is, for the circuit shown in figure, V1 is equals to 8 volts DC, I1 equals to 8 ampere DC, the voltage VAB in volt is dash. So you are supposed to find this voltage VAB. Now students, so let us make one thing. Let us make this point is my ground volts. If you see, if I am making this point is ground, this node is same as this node and is same as this node. So this is the same node B, right? So VAB is generally given by VA minus VB, but the reference node which I have selected, so here B node is connected to ground, so VB equal to 0. So VA minus 0 is basically VA. So VAB equals to VA. So, so what I'll be doing is, so let us say that this node voltage is VA. Not let us say this node voltage has to be VA, right? Because this is the A node. So now we can write a simple nodal equation here that will give me the value of VA. So let us write that equation. So you get VA minus how much? V1, right? Because see, this node voltage how much? Because if this is point is ground, so I am saying that this is also ground because the same node. And because V1 is equals to 8 volts, that means this node voltage is 8 volts. Okay. So for this branch, if I am writing, so VA minus 8 divided by 0.5 plus VA divided by 3. I mean VA minus 0 by 3. VA minus 0 by 3 plus VA minus 0 by 3 equals to 0. Isn't it? So for this branch, VA minus 8 by 0.5. For this branch, VA minus 0 by 3. And for this branch, again VA minus 0 by 3. Because VB is 0. Because this is 0 volt, this is also 0 volt. So VA minus 0 by 3 for this. Again VA minus 0 by 3 for this. You can simply get VA value from this. So this, if you simplify, so this is 2 VA minus 16 plus VA by 3 plus VA by 3 equals to 0. So 6 VA minus 48 plus VA equals to 0. So 8 VA is equals to 48. So this implies VA equals to 48 by 8. So that happens to be 6 volts. So your VA is 6 volts and VB is 0 volts. So naturally your VAB is VA minus VB, 6 minus 0. That happens to be 6 volts. It is a very simple and straightforward problem. So just by making 1 point ground and by writing one simple equation here, we are able to get this VA. So answer is 6 for this. This question is asked in GATE 2023 of electrical. This is from network theory subjects and from transient analysis topic. The question is, the value of parameters of the circuit shown in the figure are, so this R1, R2, R3, LC, these values are given, okay. For time t less than 0, the circuit is at steady state with the switch K is in closed condition. If the switch is open at t equal to 0, the value of voltage across inductor at t equal to 0 plus is how much volts? So this question is, students, based on t equal to 0 plus model. In such kind of cases, what we do is, we first find the initial condition of the network. That is, what is the initial inductor current and what is the capacitor voltage, initial voltage before the switching. And because switching is happening at t equal to 0, we'll be interested to find what is IL0 minus and what is VC0 minus. Once we get it, so we'll be drawing the circuit then, and that will, from that circuit we'll be getting the desired parameter, which is VL in this case. Okay. So first of all, at t equal to 0 minus, network is in steady state, switch is in the closed condition. So switch is closed. And you know, for step input or DC input, so if the network is in steady state, so inductor behave like short circuit and your capacitor behave like EU open circuits. So considering this, if I draw the circuits, so how does the circuit will look like? So this is the switch is in closed condition. This is R3. R3 is 3 ohm. And then this is your 10 ampere DC current source. And then you have, this is R1, whose value is 2 ohm. And then the inductor, it is short circuits. And then you have R2. And then you have this capacitor like this. And it is like this. R2 value is given as 2. And R1 value is also given as 2 ohm. So this voltage is what I mean by VC0 minus, and this particular current is what I mean by IL0 minus. Yes or no? Now first let us find what is IL0 minus. Once you get IL0 minus, you can easily get what is VC0 minus. So IL0 minus, how do you get? So you need this current, right? This is what IL0 minus. Because this path is open, so this branch current is 0 ampere. So this branch current is IL0 minus. So this branch current is also IL0 minus. So this current source, this is pumping a current of 10 ampere. And from here, there are two paths. One is this path of having 3 ohm resistor, and one is this path of having 2 ohm resistor. Because this path is open, this is kind of a dummy path. So this 10 ampere will getting divided across this and this. So if I ask you to write the current division equation of IL0 minus, this happens to be net current 10. You need the current in this branch. So opposite branch resistance is 3. 10 into 3 divided by sum of them, 3 plus 2, that happens to be 5. So 30 by 5, that happens to be 6 ampere. So you got one parameter which is 6 ampere. Now you need this VC0 minus, right? VC0 minus how much? So VC0 minus, this will be 2IL0 minus, because, so this is VC0 minus. The drop here will be 0 because current passing in this branch is 0. So by Ohm's law, this drop is 0. So if this drop is 0, so in this loop, if you see, so this voltage should be definitely equal to drop of this. This voltage should be definitely equals to drop of 2 ohm resistor. What is the drop of 2 ohm resistor? Current, which is IL0 minus into 2. So that's why I'm writing 2 into IL0 minus. So 2 into IL0 minus is basically 12 volts. Yes or no? So you got these two parameters. Now we'll be drawing this circuit at t equal to 0 plus. At t equal to 0 plus, so first thing is your switch is open, right? Because the switching is happening at t equal to 0. So switch is open at t equal to 0. So a instant at t equal to 0 plus, which is greater than 0, definitely the switch is in the open state. Switch is open. So in this case, what happens? Your inductor, it should be replaced by an ideal current source whose value and direction are same as IL0 minus. Similarly, capacitor should be replaced by ideal voltage source whose value and polarity, it should be same as VC0 minus. So considering this, if I draw the circuit, so how does the circuit will look like? So let me copy this. So your switch is open, right? The switch is open. This is R3 whose value is 3 ohm. This is the current source whose value is 10 ampere. And then you have, this is R1 which is 2 ohm. And then inductor, it should be replaced by ideal current source whose value and orientation is same as IL0 minus. So IL0 minus value is 6 ampere and direction is this. So direction I'm putting from left to right and value is 6 ampere. Right? Fine. This is fine. And then this is your R2. R2 is 2 ohm and capacitor voltage VC0 minus we obtained with respect to this polarity. So how much was the value we obtained? It was 12 volts. So this is your plus minus, this is your 12 volts. So this is what the situation is. And what we are supposed to find? So this is the network which is valid at t equal to 0 plus. And you see the polarity of VL. So here this is plus minus VL. So this voltage you have to find it out. Right? So how do you get this voltage then? So how do you get this voltage? So to get this voltage, okay, so see, this current is 10 ampere, right? So this current is 10 ampere. So this path is open. So this current is 0. So this current is coming as 10 ampere, right? This current 10 ampere. And this branch current, so this branch current is already 6 ampere because it's a current source of 6 ampere. So this branch current is 6 ampere. If this is 6 ampere, then naturally by KCL, this current has to be 4 ampere because the incoming current is 10 and from this node, the outgoing current should be 6 plus 4, it should be 10. So if this is 6, this is 10, this has to be 4. So now, you know this, in this loop, you can write a simple KVL equation. So that will give you the corresponding value of the VL. So wherever current enters, plus 2 minus, wherever current enters, plus 2 minus. So I have given the polarity. Now we can write the KVL equation. Minus to plus VL, minus to plus 2 into current is 6, plus to minus 2 into current is 4, plus to minus 12 equal to 0. Minus to plus VL, minus to plus 2 into current is 2 into 6, plus to minus, I'm moving this way, right? So plus to minus means minus, again 2 into 4, and again plus to minus, so minus 12 equal to 0. So VL plus 12 minus 8 minus 12 equals to 0. 12 cancel out. So the VL happens to be 8 volts. So VL happens to be 8 volts. And because this is the network valid at t equal to 0 plus, I would say that VL of 0 plus equals to 8 volts. So this answer is 8 volts. So this is a simple problem, okay, and general model problem. Every year one question is coming from transient and many times it is from t equal to 0 plus model. In this kind of cases, just we have to obtain the initial condition, then draw the network at t equal to 0 plus by replacing the inductor by ideal current source, capacitor by ideal voltage source, and then by writing the desired set of equation, you have to get the desired parameter. So that's what I did. First I obtained the initial condition IL0 minus, VC0 minus. Then I have drawn the circuits, and from here by writing a KVL equation, we got the answer as 8 volts. So answer is 8 for this.